Hello, everyone. This is Raphael again from HM Academy. We have Olympics back for part two. If you missed part one, Olympics went over their suite of tools. They have a suite of tools mainly focused towards early stage smart contract development. So you find your bugs as you're writing your code. We have Sarah and Anish from the Olympics team. Please go ahead, take it away.
Awesome. I think we've got some people in the waiting room as well, if we want to let them in.
Whoops.
Okay, perfect. So, hey guys, yeah, welcome to part two of the Olympics Build Safe, Ship Fast series. Today we're going to dig into part two, which is focused around being audit ready for every single release. So it goes beyond just kind of tooling and what you need to do in terms of testing, and also some of the other pieces that you should be focusing on as you head into an external audit. Yeah, quick recap on Olympix and how we got here. You can go to the next slide. So as you guys all know, tons of hacks are taking place in the space at all times. You can see the hacks as they kind of grew across 2021, 2022, bit of a dip in 23 and 24, largely due to the bear market and just there being less TVL flowing through the space. And then we're projected to be at the biggest year to date in terms of exploits by the end of this year. And we see around 5 major exploits in the EVM space every 2 weeks, which we cover in our newsletter and do kind of postmortems on. Next slide, please. So yeah, massive hacks in the space. But again, as we kind of touched on in the first part of our presentation here, thankfully, a large amount of these hacks that have happened are preventable with the Olympix tooling. So we do a postmortem on every single hack that takes place in the EVM space, and we run our tools on the pre-audit commit and see if we can flag the vulnerability that leads to the exploit. And in 60% of the cases where hacks have happened over the past year, the answer is yes, we could have prevented it. So well worth looking into the Olympix tooling to slot into your development lifecycle and your audit prep, so that you're adding an additional layer of security that's scalable, cost effective, easy to use, not just another costly audit to try to plug that gap. Next slide. And so, yeah, Olympix is a stack of tools that enables engineers to surface vulnerabilities earlier in development, which means that you're adding additional layer of security, you're reducing audit reliance, you're getting cleaner audit reports, which means you're signaling stronger security to your stakeholders. It means quicker remediation cycles. It means that you're more likely to find additional bugs or allow the auditor to find additional bugs because you've cleared away low-hanging fruit and a whole bunch of other types of bugs in advance. And overall, you're just able to deploy safe code faster. So digging in on the next slide to the kind of security lifecycle here. In our last presentation, we looked at the left-hand side, the green stuff there, continuous development. So there's 3 tools that integrate directly into the development lifecycle. Today, we're focusing on the right-hand side here, which includes our tool Bug Poker, but additionally, all the other pieces you need to be audit ready before you go into external audit. And so next slide. So that's part 2. Here we go. I'll hand it over to Anish to kind of start walking us through this checklist. And if you guys have this recording, I would definitely recommend screenshotting each of these slides on this checklist, because this is something that you can run through before anytime you go to an external audit. And we'll go through all the pieces that include tooling, that include OPSEC, that include different types of testing that you guys need to do, everything you need to do to get the most out of your external audit.
Sorry, my bad. All right, let's get started, guys. So this audit checklist is I think a very interesting tool in the pre-audit lineup. And if you've seen that teams get very much cleaner repositories after they have went through the audit readiness checklist, and it often gives them much nicer audits with much more valuable information than if they would have gone through the audit without the checklist. So as Sarah mentioned, yeah, definitely recommend if you guys follow through this, especially if you guys have an audit coming up. All right, so let's get started. All right, so starting with the first thing, static analysis. We think static analysis is a very necessary tool for the Solidity ecosystem. It's a very easy tool to get up and running, and it often will give you instant results. Whatever tool you're using for static analysis in the market, we recommend you run static analysis across all your code bases, especially the ones that are going to be audited soon. Uh, Ideally, you would integrate it into your CI and have this continuously be running on all commits. For most big teams that we work with, we see that they block on these. So you should not allow new branches to be merged into your main branch without, for example, clearing away all the highs and mediums of static analysis results. So we recommend you that you review and resolve all the high severity issues that are being flagged by static analysis. If you don't think that some are true positives, then you should explicitly mention those to be false positives and remove them away. And we ask you to look at least look at all the mediums and lows, and then decide whether these need to be resolved or not. Okay, moving on. Code coverage. So we ask you to have at least 90% branch coverage across your code base. We think that code coverage is not an amazing metric, but it's table stakes for creating a secure repository. You should know how your source code behaves, how your and your test suite should have coverage for all these behaviors, for all these edge cases. It maintains code hygiene, and it almost forces your smart contract engineers to think about all the possible edge cases that might exist for your code bases. So we think that 90% code coverage is very important. It will also help you to get better output from the other security tools that you might be able to use in the ecosystem. Uh, n- and then moving on, you just not only need 90% branch coverage, but you need specific test cases testing your critical functions. So if you have flows that will definitely work with money, if you have flows that, for example, will reset your admin, if they are resetting your time logs, if they're pausing, or etc., you should definitely have specific test cases testing the various different branches or behaviors that might exist within those operations. Moving on, mutation testing. So this also kind of builds up on the previous point, because for good mutation testing, you need good code coverage results. So we recommend once you have 90% code coverage, you start running mutation testing across your code base. We ask you to have at least an 80% mutation score, and again, if you for your most critical and important contracts, you should have much more higher mutation score coverage, if not 100%. Right, moving on, fuzz testing. We have seen this time and time again. Fuzz testing is really important and really good at finding bugs, especially stuff that deals with external input. If it has a lot of math, if it has precision, cost conversions, if you have money again, if you have like ERC20 tokens being transferred from some flows, you should definitely have multiple fuzz tests around those behaviors. This can show up very interesting and complex cases which humans can't even think of, right? And so we definitely recommend you having fuzz testing around all these different functions. Okay, moving on. So then the next step is we recommend you run bug poker. What is bug poker? But starting with the name. So bug poker, the poker in the name stands for POCER, which means that it's an AI audit agent which will create POCs for all the vulnerabilities that we describe to you. So essentially, you run this on your code base. It will go through all the contracts. It will do a lot of analysis, so it uses this internal Olympix engine, which uses a bunch of stuff. So it uses a few of the front end and mid end passes of the Sol-C compiler that we have recreated from scratch. It uses our IR, it uses symbolic execution, and it uses a bunch of custom detectors that we have written down. Uh, Mix all of this, and then you get analysis per unit per contract of your code base, and then for each of the unit that you might have, so for example, for each of the function that you might have, you'll get potential vulnerabilities that might exist in that code base. Not only that, for each of these findings you'll also get a POC, and that's what the name bug poker stands for, and that POC will verify whether this is a true positive or a false positive. So you'll get clear true positive vulnerabilities that might exist in your code base, much like a good audit would give you. All right, and now let me show you a quick demo on what you get when you run bug poker. All right, so as I said, the interface for bug poker just looks like an audit to you. So you'll get essentially something like this, which is an audit report. Uh, in this audit report, as you'll see that we scanned through all these different contracts, which was this was just part of a scan we did on EigenLayer on their slashing release. But these were the unit the source codes that we scanned. For each of them, we found these many exploits. So this is what one exploit looks like. Again, pretty standard. Will show you what unit, what location this exploit appeared at. It will give you a description explaining exactly what the problem was, and then finally the POC that we mentioned. So it will give you a compiling forge POC that exactly will point out how this was exploited, or how we think this could be exploited in the future. And this POC was actually executed on our side. So this will definitely compile and pass for you. So you can be sure that this is like a real POC. And this is what you get essentially for all your units. You get a bunch of findings which will with along with the POC. Uh, so yeah, that's bug poker. Any questions up to now? Or we can take the questions at the end of the presentation. Okay,
Yeah,
going
yeah.
back to the Sorry. So going back to the presentation, the next step in the checklist is tooling and environment. So we recommend that every tool that you use in your repository, so for example, if you use Soldier, if you use uh, a certain coverage util, if you use Slither, any tool if you use Olympix, any tool that you use, it should be properly documented, and it should be runnable at the audit commit. So if you ship off a particular commit to an auditor, the auditor should be able to run all those tools just like you would. We often see that there is a difference between developer setups and the Git branch main. And this often creates like unnecessary cycles of communications between the auditor and the team, which of course like wastes valuable time and money. So we definitely recommend you resolve all those common tooling issues, make sure coverage runs, etc., before you ship off your code to the auditor. Okay, so the next point in line was error and exception handling. So this kind of comes from the first test generator, or sorry, from the first testing point. The idea is that when you ran first testing, you must have seen a lot of bad parts, the non-happy parts essentially. And for those non-happy parts, if there were just standard rewards, it was just an EVM error, or just the standard EVM reward, we recommend you having specific errors and like exception handling mechanisms there. Like if these were paths that you were not expecting, you should definitely have now that you have seen this path occur, you should definitely have like helpful error message events that you might need, etc. Uh, and then make sure all these edge cases are being tested and covered for properly. Right. The next step is dependency management. This is very important. We have seen multiple bugs and hacks happen because of bad dependencies that you inherit from. We recommend that if you can, then most of the dependencies that you are using should be the latest version that are possible. It's also not that hard to do a quick CV essentially kind of search for these findings. So if you are, for example, using OpenZep 4.5 or let's say 4.6, then you can look up if OpenZep 4.6 has a known high vulnerability, right? And we recommend you do it at least for all the top level dependencies of your project. Um, the final point here is that you should have a minimal set of dependencies that you need. We have seen that a lot of times there's unnecessary code in the repository, mostly stale dependencies, multiple versions of dependencies because different parts of the code needed it and no one forgot to change it. That's also detrimental both for the auditors and for any tooling that might interact with your system. Okay, documentation. I know this is a hard one since all these crypto teams don't have a lot of capability, but I think this is a very important security posture point. You should have good documentation for, again, all tool usage, deployment instructions. If you have deployment scripts, if you are using certain RPC URLs, private keys, you should have good documentation around managing those. How would a newcomer to the repository be able to see those or enter those? Their APIs, any important functions that you might have in your code base. So, for example, again, the critical functions that I mentioned that might do important operations in the repository, they should be specifically mentioned in the documentation. so that the auditor, for example, could be pointed out to, for example, a particular contract and a particular function, and they can pay more attention there because you might preempt that there's, again, like more money there, more traffic flowing through that function, etc. Uh, Once you did all these steps, you must have made a lot of fixes. You should maintain a list of these resolved issues, and this, I think, is also just a good practice to do in any cycle. This is close to some like a Kanban board or something where where you list down all the issues that happen and that were fixed. This just helps you in review post fixes. One, of course, for checking efficiency, and two, if accidentally another issue was created in this process, you can exactly find out like where this was created and due to which fix. uh, we recommend that you have a clear and concise audit readiness report. What we mean is that if you have used any of these tooling that we mentioned, static analysis, mutation testing, etc., you should have all of these figures somewhere and note it down. And for example, say you're choosing to allow 5 mediums to pass through your code base, or if you're choosing to allow 10 mutations to survive through your code base, you should mention this in the audit readiness report so that the auditor can also then look at these mutations and then double verify essentially whether these are actually false positives, or there are cases where these might be true positives or not. Okay, so this is now a post-audit fix point. So after you run an audit, they suggest you a bunch of fixes. We recommend you have a good peer review guideline system so that at least two people on GitHub need to verify and say yes to a fix after the fix has been, or on a fix PR essentially, after a suggestion is being implemented in the repository, because you don't want to accidentally open up a new bug while fixing these old bugs. Okay, so this is now an OPSEC point. This is also very important. We have seen bugs happen here all the time. Um, this is easier said than done, but you should ensure as much as you can all your deployment scripts and services are as secure as it is possible. Ideally, we have seen that most deployer accounts should be deleted as soon as they're deployed, of course, with permissions transfer right at deployment to their respective roles. There should be minimized centralization of power. There should be multi-signature EOAs, of course, with time logs, etc. The private keys ideally would also be distributed. For example, something using SSA or an external service to distribute these private keys. We recommend storing those in physical gapped systems. Make sure that and this is the point that gets overlooked all the time, make sure that all your employer devices, all your deployer devices, social media accounts, etc., are kept safe and secure, and they should be treated as the same level of importance as your code base, for example, right? Or your deployed contracts or your private keys, because any of these can become like real vectors for hacks, whether that be a phishing hack, whether that be a private key hack. That's equally as bad, if not worse, than like a smart contract bug that might happen, right? So yeah, once you do all of this, do a final code testing pipeline again, run unit testing again, run static analysis, finally run mutation testing again. Make sure to log it all down in one file and have this available in your repository, both as a badge of trust for your end customers, but again also for auditors, to let them know everything that you have already done and anything that might lack enough coverage, and then that the auditor might need to focus more on. Once you do that, you should have a clean repository with good version control tags. Um, Make sure that you, again, version it properly, have done a code freeze for at least 2 weeks before that on this commit, and then finally give them access to all these reports, issue trackers for the issue log that I mentioned, for example, the Kanban. And then finally, you would finally discuss audit strategy and address any final concerns that might remain in the team. Right, that's the audit checklist. Any questions?
I had a question about like deleting the deployer. Why would you do that? Or like why is that necessary to do?
Good question. So we have seen multiple things. So it would, of course, depend on if you're using an external service for deployer or you own the systems that's deploying on. We have seen that there have been deployer takeovers. So there were contracts that were deployed by the deployer, and not all the permissions were transferred away, right? So that EOA still had some permissions which, for example, could pause the contract. And of course, you don't want that to happen, right? And like those private keys somehow happen to be less secure than the ones that you already own. So the idea is that either own the deployer and own the security of the deployer, or just strip the deployer away from all the permissions, or just deconstruct that contract if you can.
Gotcha, gotcha. Don't play both sides. Cool.
So it can be both. The deployer could be an EOA, and then it could just run a deployer script essentially. It could also be a deployer contract. Again, like this could be like a multi-sig, etc. So you can choose it to be either way. Of course.
Any other questions?
Yeah, any other questions? Okay, awesome. Oh, there's one. How often do you have false positives using this tool?
So, good question. For bug poker specifically, we'll already give you a true positive and false positive classification because with the POC. Uh, a false positive in the POC could mean that the bug poker is making assumptions that you might not agree with, and it's often because there are things outside the code that exist, right? For example, if I find that there's no access control on this function and anyone can take money away from this function, you might object that there would never be any money in this contract. So that is fine if anyone can take it away. It's just impossible to know that just looking at the code. So there would be false positives like that, which often end up being like acknowledgements on these auditors. Like operationally, these reasons could be avoided, and we see a fair bit of these because like often there are a lot of undocumented assumptions for these code bases. So we see approximately 40 to 50% of findings to be that.
Cool.
Sure.
Here we go.
There's another one. I'll read it out. In terms of testing requirements, what additional precautions are to be taken when developing contracts that use coprocessors, specifically FHE coprocessors?
Good point. I'm not specifically aware of those coprocessors, but we recommend you have multiple layers of testing. So you should have unit tests that specifically test for your intended behavior and all the bad parts that you can think of. And then you should have integration tests that build up on all these unit tests. And on top of that, you should have fork tests. So if you're using external libraries, for example, if you're using Uniswap, if you're using PancakeSwap, etc., you should have tests that fork on essentially a particular block and then build on top of that, and to make sure that your unit tests do work with these external pieces well as well. And then of course we should have a good amount of fuzz test and invariant test that again like just test your functions in like a variety of different ways.
Cool.
Sure.
Any other questions? Okay, perfect. Yeah, so once again, I'd recommend if you've got the recording here, you're looking at the recording, screenshot those bits and pieces so that you can run through them as you do your next prep for an external audit. And of course, check out Olympix to see if any of the tooling could be a good fit to help you guys during your continuous development and during audit prep. You can go to our website. Yeah, we'll happy to set up a custom demo for you guys and show you how the tools would work in the context of your code. Oh, we've got one more question as well. If you do fuzz testing and you find out some bugs that you don't know how to handle, what do you do?
That's an interesting question. Can you explain like so suppose you found a non-happy path where where there was like a weird reward, or did you find another path that might lead to, for example, like a hack?
Also, feel free to unmute if you want.
Mhm. Sure, interesting. So, I mean, of course, this depends on the specific case. Often it's very useful. For example, if you're using something like Foundry to write your first test, it will give you those exact function calls that lead to those cases being possible. So, for example, if it there was this function call chain which required this parameter, and this parameter, and after which this hack could be possible, you what you can do is just start looking at your code, take those parameters, write it down, and then see what's happening, exactly what branch you're going down when you're applying these parameters. What this will give you in your mind is like a path where and like you can trace this back in your code, and it will give you this path where this hack could occur, right? And hacks always occur because you made an assumption at a certain point in your code which was not substantiated by your code base. This might make you add like a require statement, because you know this assumption was that like this bad state can never happen here. This could make you write another function that checks for this different state to occur before you can get into this function, etc. um, One thing I would also like to point out is that if you have a general idea, once you look at these function parts of what these hacks mean, or sorry, of like what this hack could be classified as, you can often look on the internet for examples and hacks that have happened before surrounding this, and there are often a lot of write-ups that might help you.
Awesome. So yeah, check out our website, Olympix.ai, if you'd like to learn more about the tools. Feel free to reach out to any of us individually. You could reach out to the Atrium team or the Uniswap Foundation team for direct access to us, and they're happy to connect you with us. Yeah, thanks again for joining our second presentation, and looking forward to potentially helping you guys build safe and ship faster.
Thank you, Sarah. Think English. Please check out our YouTube channel, check out part one, and review this episode again. Bye.